What does it mean for a sequence to converge? Let's find out. First of all, a sequence is going to converge when it gets close to a certain number. Let's say we looked at this particular example here. Does it approach a certain number? So let's describe the terms in our sequence. The first term, we're going to call that A1 or A sub 1. The second term in our sequence, we're going to call that one A sub 2 because we're writing a little 2 at the bottom there. The third term in our sequence is A sub 3. And we're going to continue to name everything the same way. So the fourth term here, what do you think we're going to call that? We'll call it A sub 4. Similarly, the fifth term is going to be A sub 5. And our sixth term we're going to call that A sub 6. We'll describe each position using a number. So for A sub 1, we'll say n equals 1. For A sub 2, we'll say n equals 2. The position is position 2. For A sub 3, that's in the third position, so we're going to say n equals 3. A sub 4, similarly, fourth position, that's n equals 4. And A sub 5 is the fifth position, so n equals 5. And then A sub 6, n equals 6. So remember that these three dots here represent that we're moving towards infinity. So there's a bunch of ways we could represent it, but let's just say that we call this for now A sub infinity, just to say that we're moving towards infinity. So let's answer the question about, as we go to infinity, does the sequence converge? Well, first of all, look at what's happening here. They're getting smaller. They're getting closer to 0. So this sequence does converge because all of these numbers are getting closer to 0. What about this sequence? Does it converge? Well, let's look at a graph to see whether it does or it doesn't. So for our sequence, when n equals 1, we're at 2. When n equals 2, we're at 5/4. When n equals 3, we're at 10/9. When n equals 4, we're at 17/16. When n equals 5, we're at 26/25. And when n equals 6, we're at 37/36. All of these numbers are very close to 1, you'll notice. So what's happening here is that we're getting very, very close to 1. Even on the graph, it looks like we're actually at 1, at that line representing 1. But if we zoom in a little bit, we'll see that we're just getting very, very close. So basically, what does that tell us? Well, as this sequence continues, when we start at A sub 1, we know n equals 1. When we get to A sub 2, we're at 5/4, which is even smaller. So at n equals 2, we're slightly smaller than where we started at. For A sub 3, our next position, we know that 10/9 is smaller than 5/4. 17/16 is also smaller than 10/9. But notice that all of these are improper fractions, meaning that there's still a little bit more than 1. So 26/25 in our fifth position is still a little bit more than 1. And it looks like we're never going to actually reach 1. We're always going to be slightly above 1 based on how the sequence is described. So does the sequence converge? Yes, it gets very close to a certain number. In fact, as we consider the behavior going towards infinity, we know that everything seems to be getting very, very close to 1. So because our sequence gets very close to a certain number, we can say it converges, and that is converging to 1. What about this sequence? Does it converge? Let's plot it to find out whether it does or it doesn't. This sequence starts out at 1, then it goes to 4, then it goes to 9, then it goes to 16. Actually, let's zoom out a little bit so we can see that. Then it's going to go to 25. Let's zoom out a little bit more. So we can tell basically that this sequence is going to continue to get larger and larger as we go on. So what does that tell us about whether the sequence converges or not, whether it converges or diverges? So the first term we know was A1. The second term we know is A2, and it is larger than the first. The third term was A3, or A sub 3. The fourth term, again, is larger, so we're continuing to get larger as we go. So A sub 4 is larger as well. And A sub 5, our 25 here, where our position number is 5, is even larger. So we're expecting that these numbers are going to continue to get larger and larger as n gets larger and larger. So as we move towards infinity, remember that's what this ellipsis mark, that's what these 3 dots represent. What's going to happen as our position moves towards infinity? Well, what we said was that these numbers are getting larger and larger. So all of this is going to just keep going towards infinity. So because it doesn't approach a particular number, we're going to say that this sequence diverges.